All right, and here is section 7.6, day 2. I hope all of you that took the ACT today and are watching this video in the comfort of your own home. Actually, no, you'd be watching it tomorrow in class. So, hope you all did very well on the ACT. But yeah. All right, except for Nathan. He didn't need a good. He didn't need.
Yeah, good luck. Gonna track down the cross country average ACT score.
If he can do math problems as good as he writes, he'll be all right.
The only smart running school is Stanford.
Oh, okay, I didn't know that. No. They're pretty smart at everything. They're pretty smart at everything.
Infographics.
Yeah,
Oregon's like big running school.
That's true. They're all right, right?
I mean, they're good enough.
I think you'd have to be smart to get into Oregon.
And Oregon kind of sucked this year. They won like 12.
Oh.
Stanford was 4.
Who was first?
BYU.
Oh, really?
It was BYU and
those Mormons. All right.
Yeah,
All
it's a 2-year gap. They go in
hate speech. The
demonic.
it was turned around. So maybe you can catch it. Maybe the computer. I'm not saying that's a bad thing to be a Mormon.
No, the Mormons can
just to clarify for anybody watching out there.
The Mormons can unfair advantage.
Is anybody Mormon in here?
Yes, we have Mormons.
No, I didn't know. You never know.
Yeah, there's
Well,
like
you can tell by looking at them.
There's Mormons don't exist.
You know what's funny? When so I grew up around this area too, right? And my first, this is going to be great because it's on. Yeah, really, I'll put that in the comments. Start at 2 minutes. My roommate in college was Jewish. And I had never come into contact with a Jewish person. Like I had never ever. So like there was that moment where and he didn't really. He lived up in Beechwood. Like he was always surrounded by Jewish people. Like it was that. Like my life with Christian people was his life with Jewish people, right? Like he was just around all the time, you know. And so we had that discussion, oh, so you really don't believe that? And I was like, no, you really don't believe that? And he's like, no, I don't. Whoa. It's like I'd never really come into contact with that kind of person. Wow. It's crazy.
We respect all religions.
We everybody, we respect all religions.
Did you wear the candlestick?
Yeah, and I learned all about his the Jewish culture, I had matzo pizza together. We had matzo ball soup. All right. Okay, so back to math. Hopefully we're all. Hopefully you skipped all past that. So we learned yesterday about E, right? E, the naturally occurring constant. E. Okay. Now remember that E is just a number. Okay, it's just a number. 2.71828 and so on, right? But what is it used for? It's used for a lot of times when things are naturally occurring, or occurring constantly. That's a better way to put it, I think. Constantly occurring. Like when we talked about that compounding interest, that was compounding not just every year, not just every day, not just every hour, not just every minute, every second, every half second, every third. It's always happening, quicker than we can even, count almost, right? So that's what E is really there for. It's a constant that allows us to take into account things happening all the time. Okay. Another thing that we can talk about is half-life. That does that same thing. The half-life of a substance is the time it takes for a half of a substance to break down or convert to another substance during the process of decay. And you guys have studied half-life before, I would assume, right? Half-life, half-life is, everything is decaying, right? Everything in the world is decaying, just at different rates, right? And that rate is set, different, elements and different substances have different half-lives. Some are a lot more, some are a lot longer than others, right? That's why things, people say, don't throw away styrofoam because it'll stay in the landfill for millions and millions of years, right? Because styrofoam doesn't break down as fast as other things. It doesn't decay as fast as other things. Now half-life is something more in the elemental level, where it's okay, if you're given a half-life of a substance at that end of that time period, half of that substance will remain. I think I talked about it yesterday, but It's not this idea of like, okay, if you say the half-life of this substance is, I don't know, 3 days. It's not like at the end of that 3 days, it's like, bloop, and like half of it just disintegrates, you know. It's naturally happening. It's happening not just every minute, not just every second, not just every half second. It's always happening. It's always decaying. Okay, and since it's that idea of that always happening, it's going to have E within the formula. Okay? So that's our formula. I would write this down. So N of T is equal to N original, N naught, N sub 0. That's the initial amount, times e to the negative kt. Times e to the negative kt. Okay, so N of T is your final amount. So there are going to be a lot of times where I'm going to say, okay, we've got 500 milligrams of this thing. What is it going to decay down to 5 milligrams? How long is it going to take to decay down to 5 milligrams? Or we've got, so we're given the initial amount, and I want to know how long is it going to take to decay to our final amount. That final amount is your N of T. Your initial amount, what I start with, you know, that 500 milligrams that I said, that will be your N naught, your N sub 0, your N sub O, the original amount. E is just the number. That's your decay constant, or sorry, not decay constant. Excuse me. That is your naturally occurring constant, the E value, 2.718, and so on. The K value is unique to every substance. Okay, the K value will change. I have to give you the K value, or I must give you a way to find the K value. And the second option is more the case that we're going to be working with. I'm going to ask you to find the K value and then use the K value. Okay? K is the decay constant, and T is the time in years. Or no, I'm sorry, not in years. It could be anything. It could be in hours. It could be that all depends on how fast it's decaying. Okay? It could be seconds. I don't know. Okay. Now this is a lot like the PERT formula. Can we pause for a moment and see how similar this is to the PERT formula? The PERT formula was for money, right? Your principal amount times E to the RT. Okay? How are things the same? Well, N naught, your original amount, is just like P, which is your principal, which is your original amount. E is still there. K is now R. Why? Because your decay constant, which changes for every substance, is like your interest rate for your bank. Okay. T is also time periods. Why do you think the negative is there? Why do you think the negative is there? It's because it's decaying, right? Hopefully your bank account is going to grow in the positive direction. The negative will happen because it's decaying. Okay. So it's really the same formula. Now we're just like plugging in different values. Okay. All right. So plutonium-239 has a half-life of 24,110 years. Holy chicken nuggets. Half-life of 24,110 years. How long does it take for a 1 gram sample of plutonium-239 to decay down to 0.1 grams? Right? Now, what we're going to do, what you normally do in science classes is you just like you just kind of like plug and chug. You have to like manually figure out what it's going to take for half of the substance to remain. So like 24,110 years, what's going to happen to that 1 gram sample? What's it going to be? 0.5. What's going to happen in another 24,110 years? 0.25. And then 0.125. And so we can kind of estimate it like that, but we're going to be a little bit more mathematical about it. So our original formula again is N of T is equal to N naught E to the negative KT. Now, we're not given the decay constant. 24,110 is not the decay constant. Okay, that's the half-life. It's not the decay constant. Now, think about this. I am going to kind of do this for a moment. I'm going to ignore what I want it to go to for right now. What I'm going to say is, I know that I'm going to start with 1 gram sample. e to the negative k. Now, what's going to happen in 24,110 years again? How much is it going to go down to? 0.5. Guys, didn't I just make an equation with everything plugged in except for k? Can't I solve for k right now? I can. You may be thinking, well, e, you don't know e. Yes, you do. It's 2.71828, right? It's just a number. So now let's solve for k. Let's solve for our decay constant. Okay, I would have to divide by 1 over to the other side, but that doesn't really do anything, right? So we're left with 0.5 e to the negative, and you know what? I'll bring the number in front because that just looks weird. Negative 24,110k. Right. All right, now how do we solve for the exponent? What do we have to do? A log. And even more unique, we have to do a natural log. Because I would say log base e, right? But it's ln of, because it's log base e of 0.5 is equal to negative 24,110k. Does that make sense? Change it from exponential form into logarithm form. Log base e of 0.5 is equal to negative 24,110. So that just means that ln of 0.5 divided by negative 24,110 will be our decay constant. So let's figure out what that is. Now, what we're going to do here is we're going to put that in our calculator, and we're going to leave that value in our calculator. We're not going to push anything else, because I want to use that number again in my future calculations. ln of 0.5 divided by negative 24,110. Okay, there's my decay constant. Okay, there it is. Okay, now I go back to this. That's just getting k, right? K is equal to this. Now we have to use k to find how long, because the question asked, how long is it going to take from 1 gram to go down to 0.1 gram? That's what I really want to know. Okay, so I want to know n of t is 0.1, not 0.5. I want to know when it's 0.1. So my original amount was 1 gram, e to the negative k, 2.87 times 10 to the negative fifth, t, right? Because I don't know my time value here. It's not 24,110. That's what we used that to find what the decay constant was. That's 1 cycle of half-life. Okay, so now let's figure this out. We would divide by 1, but we don't really need to do that, right? So we're 0.1 is equal to e to the negative. I'm just going to write negative k t. Right? Okay, so now we change it from exponential to logarithmic. Ln of 0.1 is equal to negative k t, right? Forgive me for not writing out the 2.87 times 10 to the negative fifth. I divide by negative k, so ln of 0.1 divided by negative k is going to be my t value. So I go to my calculator and I say ln of 0.1, close my parenthesis, divided by, I want negative of the last thing that that it gave me. Negative, if you hit second and then the negative button, that's negative answer. Okay? ANS answer. So that's going to give me that. There it is. Okay. 80,091.686. 80,091.686 years. That's how long it's going to take. Now, does that make sense? Like, think about it logically. I want to go down from 1 to 0.1. We said 1 cycle of half-life was down to 0.5. 2 cycles of half-life was down to 0.25. 3 cycles of half-life to get it down to 0.125. So it's really close. It's probably just a little bit more than 3 half-life cycles. Well, a half-life cycle was 24,110 times 3. Yeah, it's probably just a little bit more. Yeah, I say a little bit more, it's like, oh, that's just 10,000. Yeah. Does that make sense though? You should be able to logically reason it through in your head too. But more exact answer is this. Okay. Why don't you guys try this one? Just try to start it. See what happens. You gotta find the key value first. There's something really satisfying about erasing a whiteboard.
Only a math teacher would say that.
Why'd you become a teacher? Well,
I'm saying
I really like to erase whiteboards.
chalkboards is bad.
No, well, some chalkboards.
You know one of those math teachers that are like all chalkboards, like some of those college
No.
professors, and all they go for is
Right, but you have to get a good chalkboard. Like there are good chalkboards and bad chalkboards. And some chalkboards you erase and you can still see it. Like you need a good chalkboard.
No,
One
you
that if you erase, it's
you
gone.
don't need a good chalkboard, you need good chalk.
I think it's the board.
It's the chalk. There's people that, there's literally a,
All the chalk is at stake.
there's a chalk market for like the math, there's literally a chalk market. There's this chalk company in Japan that went out of business and people bought hundreds of thousands
I
of.
think it's the board.
It's
I
the
think
chalk.
it's how textured the board is.
Have you
Like
looked at
how much it holds on to the chalk.
Ian,
Have
only
you
you
looked at
would
any
argue
story
this
on-
video.
on-
Isn't chalk just like
Powder.
CaCl2? Like isn't it just
Ask
like
it.
calcium chloride, right?
Ask it,
Like there's no like uniqueness about the chalk.
ask the
there?
good professors at like Stanford.
Okay, this is a Mr. Wolf question. Ask him about chalk. Isn't that just like a chemical compound? Like isn't that just
Mr. Laubach.
Maybe Mr. Laubach?
But there is, like chalk, like you have a good chalkboard, but chalk is like.
I don't know. I think you're wrong.
There's a good
I
story.
think you're wrong.
I can direct you to a good story about it.
You're wrong.
I have a
It's
story.
probably fake news.
Oh, yeah.
Oh.
Because there's literally like math teachers. that are-
Anything that disagrees with me is fake news. Sorry.
I just cannot talk in this class anymore. And now, and
No,
now
it's just because you have so many opinions that when you do have opinions, we have to fight back. Does that frustrate you?
we should just give these people a whole lesson on chalkboard.
I don't know.
All right, so we've got a 650 milligram sample of chromium-51. I want to know, the half-life cycle is 28 days. I want to know when it's going to get around or get down to 200 milligrams. So think about it. One half-life cycle is going to be 28 days to get it down to 325, right? Two half-life cycles, well, what's half of 325? 325. What would that be? 162.5, right? So it's like, yeah, thank you. You're right. So it's going to be a little bit between 1 and 2 half-life cycles, right? So we just have to figure out what that's going to be. So I don't know, like I'm going to guesstimate like 40 some days, right? Okay. Now, let's figure out Let's figure out the decay constant. We want to know when 650 milligrams, we know that in 28 days, how much is my 650 milligrams going to go down to? 325, right? So now I solve this. Let's solve for K. Divide by 650. What are we always going to get here? We're always going to get 0.5, aren't we? Because this is half-life. We're always going to get 0.5. And you know what? I'll do negative 28K. We are right here?
I don't know where you got the 425.
That, you just have to figure out one half-life cycle of it. Is it 650 gonna drop down to 325? That's half of 650. In 28 days? So I can create this equation knowing the half-life is 28 days to find the K value. Now, so we've said here that we're always going to get 0.5 if we run it like this, aren't we? So can we just go straight to this? 0.5 is equal to e to the negative half-life times k? Yes, and we can even go a step further than that. Aren't we always going to turn this into a logarithm? So aren't we always going to say ln of 0.5 is equal to negative 28k? Yeah. But aren't we always going to do this too? ln of 0.5 over negative half-life? So we can kind of like derive an equation that just solves for k directly if you really want to.
That's a lot of effort.
Sure, well, yeah. But it's really always just going to be natural log of 1/2 divided by the negative half-life. That's your k value. Natural log of 1/2 divided by the negative k value. Or negative half-life. All right, so ln of 0.5 divided by negative 28 gets us, there it is, that. Oops, covered up my answer then. That's my k value. Okay. Don't look at any of that. Okay. Now, I have to use that to figure out how long it's going to take to decrease down to 200 milligrams. So we say 200 is now so this was all like prep work, right? 200 milligrams is my final amount. My initial amount again was 650. E to the negative 0.0247 times T. That's a T. Okay, now T in this case is in terms of days, right? Because the half-life was 28 days. So when I get my final answer in the end, I have to interpret it as days. So let's do this. I divide by 650. I get 200 over 650 is equal to e to the negative 0.0247 t. I take ln of this thing. Now notice that I'm not going to run that calculation. I don't want to lose that k value in my calculator. Negative 0.0247 t. And then I divide by the negative 0.0247. ln of this thing divided by 650 divided by negative 0.0247. That's going to be equal to t. That was weird. I said 7 and wrote t down there. Weird. All right. So I do ln of 200 divided by 650 divided by negative answer. The reason why I did all that, I didn't run any other calculations so that I could just put second answer. 47. Did I say like 40? That was kind of all right. I'm going to run that again. Didn't see that. Oh, I lost it. I lost it because I ran a different answer. Darn it. What was it again? 47 days? There we go. Sorry. Does that make sense? I'm gonna do another one of those. Yeah. There's not one on here, so I'm just gonna make this up. So sorry if it comes out weird. Labrictonium has a half-life of 48 minutes.
Whoa.
Class period. How long does it take for a 60-gram sample? Yeah. To decay to, I don't know, 5 grams. I'm gonna show the work to find my decay constant. Okay, so we've got, 60 grams. I wanna know how long I know how long it's gonna take to decay down to 30 grams. It's e to the negative k times 48, right? We know that this is always gonna be a 1/2, e to the negative 48 k, and this is always gonna be an ln of 0.5 is equal to negative 48 k. We divide by negative 48, ln of 0.5 divided by negative 48 is gonna be equal to ln of 0.5 divided by negative 48. Oops. Okay, that's my decay constant. That's my K value. Okay.
Formula apply anywhere else in life other than Half-Life, so this is just specifically for Half-Life. Does this formula apply anywhere else in life or just Half-Life?
Yeah. Didn't I just relate it to the first formula? Isn't it like the same thing?
Yeah, but now, this one, we've only done Half-Life questions.
We
Right?
just started.
Yes,
We were like,
there's
10
many.
minutes ago.
Anything that occurs naturally, like that's happening all the time.
Can I give an example of something else that we do like?
I'm not a science teacher. It's more a sciencey thing. Dr. Lambert. There is a Dr. Lambert. My cousin is a Dr. Lambert.
Nice. Actually?
Yeah. She's not like a real doctor. I'm sorry. She's a real doctor. Sorry, she's a real doctor. But like she's not a medical doctor. But she's a PhD in English.
Oh, so, no, okay, I can
She
see why.
teaches at the
you're not-
University of Finland.
I can see how people get offended by saying not a real doctor.
Right, I know. She worked really hard for those two letters. I'm really sorry. All right, sorry, I'm just digging myself off. I should just scrap this video.
Yes.
Seventh period. Yeah.
Yeah, because you're doing it.
All right, so we want to know when it's going to get down to 5 grams, starting at 60, e to the negative 0.0144.
Mr. Lavick, you hate Mormons, so you don't believe in doctors.
Yeah, really. I don't believe in doctors. Right? All right. So 5/60ths is equal to e to the negative 0.0144t. And now we say ln of 5/60. And I come to think of it, I think her husband also got a doctorate too now.
How is she still a lab?
Well, she's by marriage.
Ah, come on.
I don't know Mr. Ladder's
Come on.
family.
My cousin Vince married her.
Let's go, Vince.
Good job, Vince. Shout out to Vince.
Shout out to Vince Laverick. Look him up. He's probably not subscribed. And I divide over by my negative k value, and I get 172. 172.07.
I did it.
Yeah.
Three hours
I'm almost CPR certified.
Yeah.
Gosh.
Let's go.
Questions about that?
It takes like 3 hours for that to be.
Yeah, 3 hours.
About.
Let's solve a couple equations real quick. So this is kind of deviating away from Half-Life now. Go ahead and solve that equation. This is something that I could have given you yesterday too. So go ahead and solve that equation. Use what you know about logarithms to solve that equation.
Let's see.
You will get a decimal, and that's okay. Decimals are numbers too.
What if I put it as a fraction?
Go for it. Try it.
What a big guy.
See if we can do it.
Isn't there like just a way in the calculator where you can just say, make this decimal?
Yeah, try it.
It's
in
there.
If you can express e as a fraction, you might, get paid millions of dollars.
Dude.
Because e is an irrational number.
I want millions of dollars.
I want all the names.
I want millions of dollars.
How do you know the price?
Let's go. Wait, what am I doing? No, I know what I'm doing. So why am I doing what?
Hey, what does addition mean?
Multiple.
right? So this is ln of 5x, right? How do I change this from logarithmic into exponential? What's my base? E. E to the first is equal to 5x. So what is x? E over 5 is equal to x, right? Which is E over 5, 0.5436. Let's just say 0.54. That make sense? Please don't just leave it as E over 5, right? Because that's it. That has an irrational number within that fraction. Let's not do that. Right? See, you can try to do this. You just won't do it. It's just gonna say no. Nah, bro. Not gonna do it. Not gonna do it. Last one here. You can say that
Number of ices large. Okay.
I hope I am.
Alright, this is right.
Oh, I see what I did.
I'll be very surprised. Oh, you just. Oh, I did. I mean, I'm not done yet.
Okay, so here's the route to take. Addition means multiplication again, right? So I've got ln of 10x squared. Ln is e log base e, so it's e to the 10th is equal to 10x squared. E to the 10th is just a number. I divide it by 10 and then take the square root. So let's take e to the 10th. And then I'll divide that by 10. And then I'm going to square root this. We got 46.9. X is equal to plus or minus 46.9. Now, do I want the plus or minus?
You're asking us.
Do I?
Yes.
Maggie, why do you say yes?
Because I like it. It's very satisfying to write plus and minus.
What but if you put if you put that answer on there and negative is not an answer, then you would be less order. So do I include both positive and negative here?
No.
Yeah.
But it started with a square root.
You say no.
Yes.
You say yes.
But also no. Undefined.
My gut says yes.
Yeah. I'm probably wrong. My gut says no.
Yeah.
Let's see what's logically.
Why do you say no? Because it's negative, right? And when you go to plug it in, a negative answer won't come out right? Why will it not come out right? Because you can't take the log of a negative number, right? That's why.
So just.
What happens if I plug this in?
Uh-oh.
I square it, which makes all things. So do I include the negative? Yes.
What?
In this case, see, didn't I say to you when we started doing these extraneous solution things that like you always have to go back in. You can't just throw out the negative because that's what we always do. You have to go back in and see, will it be positive? Yes. Yes, it will be positive, right? If I have an x squared, then it will be positive. I will never take the log of a negative number. Right? Okay, so there we go. All right, everybody, have a great day.
We love you, Mormons.
I was just thinking about that.
Wow.
Wow.